Have you ever wondered what is source of creaks in your bike frame? Or perhaps have you considered single piece bottom bracket installation? If so, then this video is definitely for you. As a precondition to bottom bracket installation, you need to be sure your bike frame and specifically bottom bracket shell meets the standard, so your installation will be smooth and problem-free. In order to do so, you just simply need to measure it. In order to figure out what is the diameter of your bottom bracket shell, you need to use measurement instrument suitable for this work. And in this section I will describe 3 different widely available measurement instruments and try to figure out which one is good enough to serve the purpose. First and the most simple instrument you can use, and most likely you already have it, is digital caliper. What characteristics such tool have? First is resolution. In this example 0.01 millimeters, and accuracy plus minus 0.02 millimeters. Resolution will tell you what is the granularity of readings you can get from this instrument. Accuracy indicates how close measurement reading is to actual value of object we are measuring. Object we are trying to measure here is bottom bracket shell, which according to BB86 specification by Shimano needs to be within the range 40.95 millimeters up to 41.00 millimeters. It's a quite narrow range, therefore we need to use instrument which will be able to measure with such accuracy to tell us if actually our frame is within the spec or out of spec. Digital caliper with its resolution of 0.01 millimeters and accuracy plus minus 0.02 millimeters offers you only 6 possible readings, which lands within BB86 specification. So you need to be careful while measuring boundary values which are close to the lowest specified value and highest specified value. For example, one reading 40.97 millimeters with digital caliper accuracy gives you quite wide range of possible values where your bottom bracket shell actually is, and this is anything in the range from 40.95 up to 40.99. The next possible measurement, 40.98, accordingly can indicate that your frame is somewhere in the range of 40.96 up to 41. So with such resolution and accuracy, you have only 2 useful readings from this equipment to tell you if your bottom bracket shell is within the specification or not. If you are getting readings which are close to the boundary values, so lower or the higher limit of the specification, you can be 100% sure that indeed your BB shell is within the specification, because accuracy range goes out of the specified range. At this point I wouldn't recommend to use caliper to check if your bike frame is within the spec or out of spec, as it has too low accuracy to tell you with enough confidence if you can go with installation or not. Next instrument you can use is inside micrometer, which has the same resolution as caliper, however almost 4 times better accuracy, which gives you smaller accuracy ranges around the readings, and it also gives you more useful readings within the BB86 spec. pointed by green colors on diagram. With more useful readings, inside micrometer can be used as go, no go gauge to estimate if your bike frame meets BB86 specification. However, still can be used to measure BB shell accurately. Despite offering better accuracy comparing to caliper, still micrometer have the same drawback, which is lack of self-centering mechanism. Therefore, if you are measuring inside diameter, you need to be quite careful how measurement tips touch the shell in order to avoid false readings. Having in mind this limitation, micrometer just need to be used carefully. Lastly, the most accurate instrument you can use is 3-point inside micrometer with twice much better resolution comparing to previous instruments and also significantly better accuracy, what gives you significantly more possible readings within BB86 spec. As we can see on the diagram below, we have 11 possible readings, with 9 of them having accuracy range which do not even touch the lowest and highest level. Therefore, this instrument can be used to assess the quality of manufacturing process, not only as a go-no-go gauge. As 3-point micrometer is quite expensive, I will use 2-point inside micrometer as good enough to measure my bike frame. I have already mentioned that inside micrometer do not offer self-centering mechanism, and therefore I would recommend to use some kind of template which will help to distribute all measurements around the entire BB shell equally spaced. Once you print and cut the template, it's a good idea to stabilize it on your frame using double-sided tape. While sticking templates to your frame, ensure both drive side and non-drive side are aligned the same way, for example 0 straight up. Before you go into measurement process, it is a good practice to verify your instruments with setting ring delivered with internal diameter in order to be sure that readings you get from the instruments are accurate. So in ideal case, when you touch with measurement tips inside diameter of the ring, you should get the reading with 0 on the scale, meaning your instrument is well calibrated and ready to perform your work. Now, once the instrument is calibrated and templated in the place, we can start measurement process. Put measuring tips inside BB shell and start to rotate the ratchet. Once the measurement tips will touch the shell, clutch mechanism in ratchet should work and you will hit the click. Once you hear ratchet starts clicking, read the value. In order to evaluate roundness of the shell, you need to take multiple measurements around entire shell. In my example, I took measurements in every 10 degrees. It's a good idea to cross out on the template angle which was already measured in order to be sure all measurements were taken in the order and no one was missed. Once finished on one side, repeat entire process on another side of your frame. It is also a good practice to take each measurement at least twice in order to minimize human error factor. Finally, here comes results. In general, all readings both from non-drive side and drive side are within the spec, However, consistency isn't as good as expected, so this BB shell isn't perfect or round shaped. However, from my observation, it looks like it's not the carbon manufacturing process itself, but there is some trace of paint plot inside of drive side shell. So one side is slightly oval shaped, while the other one is slightly better and more round shaped. Anyway, the final conclusion is this frame is good to go with a single piece bottom bracket installation, and I'm not going to do any corrections on this frame. Now some additional practical advice how you can take an advantage of instrument with analog scale. So in general, resolution of this micrometer is 10 micrometers. So every single line on the scale is 0.01 millimeter. We are just crossing to 40.5, 40.93, 94, 95, 96, and if you end up in the situation you are close to highest limit in the specification, you can take additional advantage of analog scale through reading between lines. So this is additional benefit in comparison to digital caliper. As we can see now, we have reading 40.97, and just by crossing the line we can see that current reading is more than 97 but less than 98. So we can approximately say it's 47.5. So through the really careful reading you can slightly improve reading accuracy on analog equipment. Like right now it's line exactly match the scale 40.99. Now slightly more than 40.99 but less than 41. So I have used this method for 3 of my readings which were 41. So in fact during the measurement process I had situation exactly like that. Just slightly cross 99 line, therefore rounding up it was 41 millimeters. However, with such reading I could assume that I haven't crossed 41 value, so I judge my frame is within the spec.